force. Now, question number 3, state and explain Newton's first law of motion. The exact relationship between the force applied to the body and the motion produced in the body is governed by Newton's law of motion. There are 3 Newton's law of motion. For Newton's first law of motion, Newton's second law of motion, and Newton's third law of motion. Now, we will be studying Newton's first law of motion. The statement of Newton's first law of motion is every inanimate body object or body. Inanimate means non-living. Newton's law of motion not apply on human beings. So every inanimate body object continues to be in state of rest or in an uniform motion Uniform means non-accelerated motion. It is moving with constant velocity or in an uniform motion until and unless acted upon by and unbalanced. This is what is important. Unbalanced. Force. Now, this is a body. This is the body. This will remain in state of rest until and unless I apply some force on it. If the force is little bit, it won't change its position. It will remain as it is, that is in rest. Now, if I apply a larger force, it will change its position. If this body is moving here with constant velocity, I want to change its velocity. That means I want to take it in accelerated motion. Naturally, I have to apply force. By applying force in opposite direction to the motion of the body may come to rest or move with or may not come to rest. Important features of Newton's first law of motion. Related MCQ. Newton's first law of motion. First law. First gives qualitative definition of force. Gives qualitative the words which are underlined can be asked as MCQ. Example, Newton's first law of motion gives qualitative definition of A. Pressure, B. Volume, C. Acceleration, D. Force. So naturally the correct option is Newton's first law of motion gives qualitative definition of force. D. Force. Second, it represents the concept of inertia. Now, the body is at rest until and unless it won't change by itself. The body will be at rest until and unless I don't apply some force on it. This inability of a body to be in state of rest or to change its state by itself is called as inertia. Third, inertia measures or represents mass or inertia is measured in terms of mass of the body. More heavy is the body, more will be its inertia. Lighter is the body, less will be its inertia. Example of Newton's first law of motion. Now, if a passenger is standing at rest in a bus which is stationary, means both the passenger as well as the bus are at rest. Now, if the bus moves suddenly, the passenger moves backside or he is pushed backside. This is example of Newton's first law of motion. Second is, if the passenger is standing in a moving bus, brakes are applied to the bus, suddenly the bus stops, the passenger moves ahead. Problem related to MCQs related to Newton's first law of motion. First is a body of mass 50 kg acquires a speed of 20 meters per second under a force of 100 Newton in time A 5 seconds, B 10 seconds, C 15 seconds and D 20 seconds. Now we know that we have force from Newton's first law of motion. Force is equal to mass into acceleration. Therefore, force is equal to mass. What is acceleration? Change in velocity. If u is the initial velocity and v is the change in velocity after time t, a is v minus u upon t. Here, given that m is equal to 50 kg, acquires the speed of v is equal to 20 meter per second. The body acquires the speed of, that means the body was at rest. Initial velocity of the body is 0. Under a force of 100 Newton. F is equal to 100 Newton. Putting these values in our equation, we get, or T is equal to m into bracket v minus u upon f. Therefore, equation 1 becomes we want to find time. T is equal to m 50 kg. Final velocity of body 20, initial velocity 0 since the body is at rest, and applied force is 100. So naturally T will be equal to 51 is 50, 52 is 100, 20 by 2 is equal to 10 seconds. Therefore, a body of mass 50 kg acquires a speed of 20 meters per second under a force of 100 Newton in time. In time 10 seconds. In time 10 seconds. The correct answer is B. 10. Stage and explain Newton's second law of motion. According to Newton's second law of motion, there is a relationship between momentum and force. Basically, momentum is denoted by P. And it is product of mass of the body and velocity. And force is mass into acceleration. So Newton's second law of motion correlates force with momentum or momentum with force. The statement of Newton's second law of motion is the rate of change of momentum is directly of a body is directly proportional to the force exerted on the body and takes place in the direction of force. Now if consider this to be a body, let initial velocity of the body is u, then the momentum of the body is P1 is equal to m u1. This is initial moment of the body. The body is given some force due to which its velocity changes to v1 in time t. Then the final momentum of the body is equal to m v1. Naturally, the change in momentum is P2 minus P1 upon T. What is this? Rate of change of momentum. Rate of change of momentum is P2, vector P2 minus vector P1 upon T. But what is P2? Final momentum, that is m v1 minus p1 minus m u1, sorry, m v minus mu upon t. I correct myself. Certain force or is applied to the body because of mass m, because of which its initial velocity u changes to v in time t. Then the rate of change of momentum is vector p2 minus vector p1 upon t. What is p2? mv minus mu upon t. Taking m common outside the bracket, in the bracket v minus u upon t. This is rate of change of momentum and it is directly proportional to the exerted force. So according to Newton's second law of motion, this will be nothing but equal to, is directly proportional to force. Therefore, we can write F is directly proportional to m v minus u upon t, or removing the sign of proportionality, F is equal to K M V minus U upon T. That is force is mass applied, mass of the body, V is final velocity, U is initial velocity, T is time. Example of Newton's second law of motion is when a fielder on a cricket field catches the ball, he moves the ball in the direction of ball, he moves his hand in the direction of ball. This will give more time for the ball and the rate of momentum will be reduced, and this will help him to hurt less. Therefore, fielder always, if the ball is moving this way, the fielder catches the ball this way. He does not move against the direction of ball. A body of mass M strikes a wall. This is MCQ related to Newton's second law of motion. A body of mass M strikes a wall with velocity V and rebounds with the same speed. Same speed. Its change in momentum is C. A body of mass M is moving in velocity V. So this is a body mass is M moving with velocity V. So naturally this momentum will be initial momentum of the body is M into V. This same body rebounds with the same speed from a wall. This is a wall. Then final momentum initial momentum was this way, final momentum is this way. They both are in opposite direction. So naturally negative sign will be there. The magnitude of initial momentum and final momentum is same, but since it rebounds back, it is negative. So change in momentum is mv initial momentum minus final momentum, mv plus mv, that is equal to 2mv. Here I have forgotten to give the MCQs. The answers are A 2mv, B mv by 2, C minus mv, and D 0. So the correct option is the change in momentum in this case is 2mv. The last Newton's law of motion is the third one, that is state and explain. Newton's third law of motion. See, according to Newton's third law, to every action there is an equal and opposite reaction. More is the action, more will be the reaction. Less is the action, less will be the reaction. So to every action there is an equal opposite reaction, and simultaneously the moment action occurs, reaction takes place. Now if a body A exerts a force on body B, then it is given by force FAB, that is force exerted on A by B. This will be in this direction. Similarly, the force exerted by B on A will be in this direction. These two forces are equal. But the directions of them are opposite. The negative sign indicates that the force exerted on B by A is exactly opposite to the force exerted on A by B. Examples of Newton's third law of motion. When a policeman or a soldier fires a gun, the bullet moves ahead and the rifle or the gun gives a jerk on the shoulder. That means that action of the bullet is forward and there is an equal and opposite reaction, that of the gun, which gives a jerk in the opposite direction for the person who is holding the gun. Second example of the Newton's third law of motion is rocket. Here, now the fuel in the rocket is pushed downward from a tiny hole with a tremendous pressure and speed. This is nothing but action. When this fuel strikes the ground gives a reaction, that means it rebounds, and reaction is this way. Because of which the rocket moves vertically upward. The launching of rocket from the ground is an example of Newton's third law of motion. क्वेश्चन बस 2 मिनट. The action and reaction forces. Forces referred to REFFERRED referred to in Newton's third law of motion. First, must act on the same body. The alternatives are must act on the same body. That means force, the action and reaction forces must act on the same body. Second, that is P, must act on different bodies. C, need not to be equal in magnitude but have the same line of action. Need not to be equal in magnitude but have the same line of action. Third, but need not have the same line of action. I'll explain you. What is Newton's third law of motion? To every action there is an equal and opposite reaction, and the line of action is same here. Look it. It never happens that action is this way and reaction is this way. Both actions and reactions are along the same line and equal in magnitude, but opposite in direction. Before that I have explained you that the force applied on a body A by B is equal to exactly equal to the force applied on body A on body B by A. That is force applied on body B by A, but in opposite direction. So this is not possible if the body is same, because here two different bodies A and B is given. So this is wrong. Must act on different body. This is correct. Why it is correct? I will explain you. These two are wrong. Need not be equal, which is incorrect. Because the force applied on A by B is equal to minus of force applied on B by A. So this is wrong, because it may be equal. Must be equal in magnitude, but need not have the same line of action. Both actions and reactions are along the same line. Therefore this is wrong. So the correct answer is must be on different body. This C could have been correct, could be correct if need be equal in magnitude and same line of action. But more correct, exact is must have reactions, action and reactions forces referring to a Newton's third law of motion must act on different body is the correct option. Thank you.